Hello and welcome to another episode of CSM Explained. Please feel free to check out our CSM Explained archive on our website, as Tom mentioned. My name is Ray Radwin and I'm an account manager at CSM. And for the next few minutes, I'd like to take you into the world of temperature measurement technology, especially in electromobility in the high voltage environment. Now, as many of you may or may not know, temperatures are the most acquired measurement channels in vehicle technology. Temperature measurement channels make up about 70% of all measurement channels sold. And this holds true for hybrid and electric vehicles as well. As a matter of fact, CSM's first high voltage module was actually a temperature module. We'll go through the importance, equipment, and of course safety of the high voltage temperature modules. And one thing you'll notice with the high voltage, you're going to see that energy loss is shown in the form of heat. So obviously, taking temperature measurement is going to be a key factor in how to see where that energy loss is taking place. There's points that we'll look at to look for energy loss, and that would be on the surface areas, connectors, anything that we could place our thermal measurements on to see where that heat is escaping. Any poor contacts or resistors will show high heat areas. High current systems will show current flowing. We can look through places that we'd be looking at high voltage measurements taken with braided shields where we might see some high temperatures that could lead to contacts burning off and potentially problems with the system. Ambient temperatures are also issues with the battery maintenance, where high temperatures or low temperatures can change the capacity of the battery and decrease the vehicle range. Ambient temperatures, hot or cold, can change the battery capacity and decrease the range. And extreme temperatures can also change the capacity of the battery, which would also lead to the ability of the electric vehicle to have extended range. Temperature measurement in e-mobility, you can obviously do some work with simulations, but even with simulations, we still need real world testing to determine whether your simulations were correct, and you can avoid potential problems through multiple temperature measurements that were done on the real world road testing. Some sensor technology for temperature measurements. The most common version of temperature measurements is thermocouples. And the most common version of that is the type K thermocouple. Thermocouples have a very good accuracy of a plus or minus 0.15 Kelvin, or about 0.4% of the measured value. It has a very wide measurement range from negative 40 degrees C all the way up to 1,000 degrees C. They're easily handled, good for instrumentation, and have good response times. Now, some drawbacks to the thermocouple are, depending on your application, you're going to need to know the type of thermocouple that you need. There are many types of thermocouples, K being the common one, but you're going to have to know for your application what's the best fit. Thermocouples are also susceptible to interference, and all the contacts must be made of thermal material throughout to ensure accuracy and quality of the data. Now, on the other hand, we also have RTD elements like our PT100, PT1000. They also have very good accuracy of about 0.15 Kelvin, and they have a pretty sufficient measuring range too, from negative 200 degrees Celsius all the way up to 650 degrees. and the RTDs have a low susceptibility for interference. Now, there are some drawbacks to the RTDs as well, where we have a little more complex cabling. It's a 4-wire system as opposed to the thermocouple 2-wire. It requires an active power supply and slightly slower response times, as well as the temperature increases, you slightly decrease in accuracy. Now, the question is, can this technology be used in a high voltage environment? Well, the good news is, yes, you can, but there's also some things to consider as well. And it's very important to consider that you have high voltage safe cables, high voltage safe connectors, and high voltage safe measuring devices, including the power supply. Let's take a look at what our standard system that we'd be using today would look like. Here we have just our typical thermocouple contacts that are exposed. You have minimal insulation on your cables. You don't have a clean entry point into your article of test, and you're still using your standard low voltage test module. So now, with this system, you're presenting danger to the user and to the testing article. So we need to find a way to take all this information we have and find a way to do it safely and have the same quality results we've had in the past. So let's start with the cable. The cable here is shown with the orange sheathing on it, has the protection of up to 1,000 volts for contact. It has various options for measurement tips, and this is the 2-wire system, so it has an allowance on an 8-pin connector to have 4 temperatures per socket. The installation gives you the option of using the Capcom adhesive pads if that's what you like. It has a temperature range of -40 degrees C all the way up to 1,000 degrees C. And on the other hand, we do have the RTDs, or the PT100. It has very thin, flexible film. It has a high accuracy, and it has good long-term stability. So now, let's take another look at this cable here. The cable here, you see the connector where it appears to be a female connector, but in reality, it's a male connector with recessed pins to avoid any accidental contact. And here's a cross view of the cable where we see the orange sheathing that we talked about before. That is EN 61010 compliant, where it is capable of contact touching up to 1,000 volts. Now, the inner blue here is also contact up to 1,000 volts, but this is done for indication purposes. Once this outer barrier starts wearing away, whether it's being chafed or rubbed on something, then we can go ahead and when we see the blue, we know it's time to go ahead and replace the cable. And here's another cross-section view. We have the thermocouple cable and then the PT100 cable. Again, we have the outer orange protection for 1,000 volts on both cables with the blue indicator as well. And even with these cables, as you notice, they're now the sensors are bundled together instead of having individual lines going into the test article. So now you can have all these being led into the test article through one cable as opposed to multiple cables trying to go through. They're still sufficiently thin and flexible, and again, they're capable of handling the 1,000 volt protection. So now let's go back to our diagram where we started off with. So we see we have the leads that we have multiple ways of mounting. We now have a single cable going through the system that allows for a waterproof connector with a strain relief. And now we have a cable that has high voltage safety up to 1,000 volts. Unfortunately, we're still left with a few drawbacks. We have a connector that still is an open contact, and we're still dealing with the standard measurement module. So let's take another look at what we can do here. Here you see we have a safe connector, which can cover up the connector as we talked before with the recessed pins. And you can see that it meets the EN 61010 standards. It has minimal creepage and clearance distances, and it has a V0 fire class protection, meaning it will self-extinguish after 5 seconds. It gives you a IP67 IP rating, and it is suitable for over 1,000 mating cycles. The connections on the plug and the module are both potted, and again, we have the cap for protection to prevent possible accidental touching or any debris getting in there. Now, it is important to understand that the connector must not be assembled by the customer. It needs to be done through manufacturing, where it can go through safety and quality assurance. So now we've taken a step forward through our diagram here. We have leads that we can apply in the system. We have a single entry point that is safely secured and waterproof. We have a cable that is 1,000 volt protected, and we have a connector that is safe from accidental touching. So now we're left with just the standard module that we used to work with. What CSM has done here is has divided the module itself into 2 portions. There's a high voltage portion and a low voltage portion. The high voltage portion takes the measurement, brings it into a low pass analog filter through an A to D converter, and then goes through an isolation barrier, an amplified isolation barrier, capable of handling 1,000 volts, and this is done per channel. That information is sent into the low voltage portion with the CAN communication, which goes off to the end user. So now you have separated the high voltage measurement safety issues from the portion that ends up, the low voltage portion that ends up with the end user. Let's take a look at a couple of the modules that we sell for the high voltage thermal measurements. Here we see we have the thermocouple version, and we have the THMM and the test bench version. This comes in the option of 4 or 8 channel, depending on the mini module or the test bench, and it works at an altitude of up to 5,000 meters. It has an operating temperature range of -40 degrees C to 125 degrees C. And the test bench module is IP65, while the mini module is IP67, which means that you have the ability to place that near your testing article, whether it be under hood, in the wheel well, wherever it may be. It'll hold up temperature and for weather or for water. And they both come with a very high measuring accuracy. Now, some things to consider about the safety of the modules. It's obviously got the high voltage safe connector that we talked about. It has a mechanical guide to protect from bending and for tightness. It has reinforced insulation for 1,000 volts RMS in between channel to channel, channel to CAN, and channel to power supply. It is tested according to EN 61010 standards in an accredited laboratory. It comes with a certificate and goes through rigorous testing. Now, these are the PT versions of the temperature modules that you can see are very similar to the thermocouple modules. And these come in a 2-channel version or an 8-channel with the test bench module. It makes use of the 4-wire technology and so that gives you the ability for 2 solid channels per connector. And it also allows for the input of PT coefficients for the best possible adjustment to the sensor. Again, it has extremely high measuring accuracy. And like the thermocouple module, it has the high voltage safe connector. It has the mechanical guide for tightness and bend protection. It has the protection between channel and channel, channel and CAN, and channel and power supply. It has the 61010 testing, and it also goes through rigorous testing. So now we've started off with a potentially dangerous situation of using the low voltage with module with just the standard cables. And now we've progressed to the point where we have a fully safe system here, where we have the leads inside the measurement environment going through a single point access with an insulation or contact proof of 1,000 volts and a connector that is relatively safe and protected from accidental touching, down to a high voltage module that separates the high voltage measurement from the low voltage communication side to keep the user safe. So now we can go on and take a look at some possible applications for opportunities for this measurement. We have the onboard chargers, high voltage batteries, obviously, electric motor, inverters, power electronics, and high voltage vehicle electrical systems. Here we have the high voltage electrical system, and we want to take into consideration the surface temperatures that we can determine whether we have a loss of energy. So as you see here, here's an example of the measurement taking place. We have a high voltage battery with a battery distribution unit, and we're measuring our current and voltage going through there. And you can see we have the high voltage thermal measurement module here, which is taking measurements off of the cable, connectors, and glands. So it's looking for any loss of heat or any heat that you can see leading to the loss of energy. Now here we see a fuel cell setup. And with the fuel cell, you have have energy from a chemical reaction that's converted into electrical energy through so-called cold combustion. This requires precise operating system, and this stack is temperature controlled by a cooling system, leading to precise temperature measurement necessary in a high voltage environment. So you see we have our measurements coming here, taking temperature measurements of what's going on through the fuel cell system. And now power electronics is obviously another place where we'd be taking thermal measurements. And for validation of power control units, we would typically see 16 to 40 temperatures throughout the components in the control unit. In this setup, you see here we have the modules taking temperature readings through a single access point into the control unit, as well as we're also taking some additional switching voltages. Now, with this setup here, you can go ahead and daisy chain all the modules together, and it all comes through on one single CAN bus. Now we'll take a look here, and we'll dig into a little bit of the high voltage battery itself and where we want to take measurements and how we can safely do that. You can see here, here's this example of a high voltage battery where we have a stack of our high voltage temperature modules, all taking temperature readings from within. So you can safely read off of the battery through our thermal modules. So when we're looking at the high voltage battery, we're going to look at some areas that we'd like to take the readings at. We'd take it at the cell level, and ideally we would have exact and reproducible sensors between the individual battery cells with high measurement accuracy. We'd also be taking temperature measurements at the battery module, and we'll take temperature measurements at the bus bars, charging electronics, the battery management system, and other components. With this, you could see anywhere from 50 to over 500 temperature measurement points. So in order to safely and more efficiently measure these 500 points, CSM has the HV temp measurement system. This is a digital temperature measurement system capable of handling up to 512 sensors in one safe cable, high voltage cable, with a measuring accuracy of plus or minus 0.1 Kelvin. Now this is comprised of integrated circuit temperature sensors and flexible circuits on a digital data bus inside the battery. It's miniaturized, highly accurate, robust. It is highly interference resistant, and you have exact sensor location and clearly identifiable. Here you see examples of the IC sensors as well as the flexible circuits. Now, in order to get all these readings into one system, we have the HV detemp controllers. These are required measurement electronics that are placed inside the battery. They are miniaturized and they are high voltage safe. Each one of these controllers can handle up to 64 temperature measurements, and each system could handle 8 of these high voltage detemp controllers, all running through one high voltage safe cable to the outside. Now, as you can see, with 8 of the modules capable of handling 64 sensors, we have a CAN bus that is capable of handling up to 512 sensors. The system is again 1,000 volts safety, with IC sensors are encapsulated. The sensor cables are capable of 1,000 volts safe to touch. The controllers have their individual ports and the high voltage safe cable to one central unit. So you have everything within this battery here coming through a single access point coming back to the central unit in order to take up to 512 measurement readings. So now as we've walked through, we see that we've had a high voltage measurement system that we created with the same idea of that we were using our standard technology that we've been using for the past number of years, that we've turned into something that we have easily mounted leads going through a single access point with a shielded EN61010 compatible cable, up to 1,000 volt protection with a safety connector to eliminate any accidental touching, all the way down to a module that separates the high voltage side measurement to the communication on the low voltage side. And then we've also discussed that we have the HV detemp system that is capable of handling up to 512 temperature measurements all through a single cable into a single unit.